we see a difference of squares in this integrand, and regular substitution will not work. So we are going to go with trigonometric substitution. The first step will be to factor out that 400 so we have our basic form. That 400 is in the denominator, and it's going to come out with the exponent that is on it. And so that 3/2 power is going to be attached to that 400. So inside, when we pull out that 400, we are going to be left with x squared over 400, which is x divided by 20 quantity squared, minus 1 to the 3/2. So now we have our basic form with a 1 in it. Well, this is a difference of squares with a trailing 1. And we will need to decide, what are we going to use? Normally with trig sub, it's sine, secant, or tangent. We know tangent is when we have a sum of squares, so it's either sine or secant. Well, it's secant squared minus 1 that is our identity. And secant squared minus 1 tells us that we are going to let x over 20 be secant of theta. And when we differentiate both sides, we will have this expression for the relationship between dx and d theta. So let's go ahead and make our substitutions over here. Out in front, the square root of 400 is 20, and then 20 cubed is what's left. Let's just write it as 20 cubed because there may be some cancellation in a moment. We'll see. Dx. Well, we look here. There's dx. Multiply both sides of that by 20, and we will have dx. So 20 secant of theta, tangent of theta, d theta. Down below, we have secant squared minus 1, all raised to the 3/2 power. We have a little bit of cancellation with our constants. We're going to be left with 1 over 20 squared. And then we have a sectan in the numerator. And in the denominator, secant squared minus 1 is tangent squared, and then tangent squared to the 3/2 is tangent cubed. One more simplification step here, so we'll have 1 over 400 integral secant theta divided by tangent squared of theta. So we have secants and tangents in this integrand, but we don't have one of our two primary rules being met. One is for secant to an even power, and the other is for tangent to an odd power. Neither of those are met, so we can't use that technique. So the next choice is to either use a Pythagorean theorem or go to sines and cosines. Going with the Pythagorean theorem doesn't make sense because that will introduce a denominator that's equal to secant squared minus 1, and we cannot split a fraction when the denominator is multi-termed. So we don't want to create two terms from one in the denominator. In the numerator, that's a good thing because then you can split the fraction. But in the denominator, we want a single term, so we're not going to do that. So we are going to convert to sines and cosines. Secant is 1 over cosine. Tangent is sine over cosine, and then we have to flip it, so we're going to end up with cosine squared over sine squared. One of the cosines will cancel, giving us cosine of theta over sine squared of theta, d theta. And now we are poised to use u substitution. If we let u be sine of theta, the derivative of sine is cosine, which is the numerator. So that's perfect. U substitution works when whatever you let u equal, its derivative is somewhere in the integrand. So that's all great news. So this is going to leave us with 1 over 400, and we are going to have du over u squared, which we're going to write as u to the negative 2 du, so that we can integrate this using our power rule. We add 1 to the exponent and divide by the new exponent. That gives us negative 1 over u plus c. And now we just need to go back to our original variable. And what we're noticing here is that we can replace u with sine of theta. So we have negative 1 over 400 multiplied by 1 over sine of theta, which is cosecant of theta, plus c. And now we have to go back to our original variable, which is x. And to do that, we use our special triangle technique. There's our triangle. And we are going to go back up to our original substitution. And let's see, secant was x over 20. Secant of theta is x divided by 20. So hypotenuse over adjacent, that's secant, hypotenuse over adjacent. And then we have to fill in the missing side with the Pythagorean theorem. So that will be the square root of x squared minus 400. And that should match what we have in the original problem. If it doesn't match, it should be real close. But if it doesn't match closely or exactly, then you know you probably made a mistake. All right, so let's go ahead and answer the final question, which is, how do we get back to x? Well, we look at our triangle. Cosecant is hypotenuse over opposite. So we are going to put an x, there's the hypotenuse, over opposite, which is the square root of x squared minus 400 down in the denominator. There we have it.